All right. Why don't we start? Welcome to session 4 of Computational Social Science Bootcamp. And it's great to see now familiar faces. Um, Today we're going to talk about toxicity analysis as it applies to Twitter data. And if you remember last time we talked about Reddit data and how to use toxicity analysis with that, there are some unique aspects of that when you work with a different type of data set. This is kind of roadmap for our bootcamp. As you know, this is session 4, and we have 2 more to go in July. So I hope you can join us then as well. The session 5 and 6 will focus on social network analysis. For today's presentation, we have 3 items on the agenda. We have guest talk by Paula Pascual Ferreira. Then I will briefly walk you through some of the practical steps. How do you actually going to go about collecting Twitter data and applying toxicity analysis? And finally, just to mix things up, we thought it would be useful to demonstrate what else you can do with data that you've collected using tools like Communallytic. So for that part, our data scientist in the social media lab, Shahnawaz Atrawala, will present a quick presentation on how to use Python and specifically Jupyter Notebook to do exploratory data analysis with the data sets extracted from Communallytic. So on this note, it's my great pleasure to introduce our guest speaker today, Paula Pascual Ferreira, who is associate professor at Loyola University, Maryland, where she teaches courses in strategic communication, communication research and methods, health communication, and emerging media. Her research interests include interpersonal, intercultural, and computer-mediated communication. Her bachelor is in political science from Princeton, MA in public communication from American University, and PhD in communication studies from University of Miami. Today, Paula will present a new paper that just came out in the Big Data and Society journal, and this paper in collaboration with Neil Alpenstein, Daniel Barnett, Rajiv Rimal. And it examined polarized discourse on wearing masks, face masks during the COVID-19 pandemic. I'm especially delighted that you're able to join us today because your case studies, well, first of all, it's very timely, but it also demonstrates the types of research questions that somebody can ask and answer using tools like Communallytic and methods like toxicity analysis. So the floor is yours. We're going to switch the screen sharing in a second, but whenever you're ready, we can start.
Thank you so much, Anatoly. I really appreciate the invitation. Let me go ahead and pin you here. And I'm going to share my screen. Good morning, everybody. As Anatoly mentioned, my name is Paola Pascual Ferra. I am an associate professor of communication at Loyola University, Maryland in Baltimore. I've been here 7 years. And I was one of the first faculty members to push for health communication to be taught in our program. So this is very exciting for me. It's, I guess, a new phase in my research career where I have been able to really explore this. And I have to say, I've been using a lot of the tools that, I'm very grateful for Anatoly to have brought to light and his collaborators, including Netlytic, which we are very much a fan of. And you'll see how I actually, for this particular study, we've been using a couple of tools. So, Communallytic was a big part of it, but also Netlytic was used for that. And then most recently, we're also using CrowdTangle. So I'm very excited of all these emerging tools. And again, thank you so much for inviting me. Okay, so I'm going to talk about the study on toxicity in social media discourse around wearing face masks in the context of COVID-19. And I wanted to acknowledge my co-authors who are not here today, but Dr. Neil Alpenstein, who was the co-founder and director of the Loyola Emerging Media Program at in the Department of Communication at our university. And then doctors Danielle Barnett and Rajiv Rimal, who are our colleagues over at Johns Hopkins Bloomberg School of Public Health and have worked with us in some of this research. So toxicity is something that we have arrived at recently. We have 2 studies out right now that focus on toxicity. One is the one that Anatoly has mentioned from Big Data and Society. And we have a second one that came out in disaster medicine and public health preparedness. And that deals with vaccine related information. And the truth is that the tool, the Communallytic tool is so, powerful for us that this is something that definitely as communication scholars, we have continued interest in engaging with. So if you're interested in looking at how we used it for vaccine related information, all of this information will be available in the recording. And also if you want, I can make the PowerPoint available to you. So how we arrived at toxicity, we had published early on in the pandemic, before it actually was declared a pandemic. We had started collecting data on COVID-19. And the way we did that was using Netlytic. And at the time, we really were just interested in looking at public opinion leadership. So who was driving the messaging, what kind of messaging, how were communities clustering? So all of that was really interesting to us. And that's how we got very familiar with Netlytic, which has become, honestly, my first to go-to place before doing anything else. So we use Netlytic for social network analysis. Since then, we've expanded to looking at Gephi and other tools, but for me, Netlytic is always the first place to go, just because it's very easy to use and it has a lot of really good information. But what we found after that is that, we were able to identify public opinion leaders, but we wanted to look at data from multiple angles. So there were other things beyond public opinion leadership that were of interest to us. And that was the qualities of the conversations and what kind of sentiment and messaging was going on. And we also, we're kind of nerdy, so we like to experiment with new and emerging tools. And we wanted something, so Netlytic has a portion where you can do some very basic sentiment analysis, and you can even manually code and create your own categories, which has been very useful to us. But we wanted to go a little bit beyond that. And we were really excited when this whole concept of toxicity kind of fell on our lab, because we really understood as communication scholars, especially someone with an interpersonal communication background. I had studied verbal aggressiveness in the past. And so we naturally understood the importance of this concept and how this could be very detrimental to any kind of public health effort. So we jumped onto that. And so we, as the pandemic progressed, it was clear that face masks became, at least in the United States, I'll speak mostly for the United States, a very controversial issue. And, obviously it did not help that it was a very contentious presidential election year in the United States. And so that issue was extremely politicized. But very soon we started seeing memes. We started seeing the emergence of hashtags. We started seeing very quickly how the debate was getting so polarized and people were getting very angry and sometimes even hateful in their words when speaking about something like a face mask. So we thought that, this was kind of a great issue to explore and to apply this idea of toxicity. And, one of the things, and I'll go into limitations at the end, but one of the things that, I hope that in the future with some of these tools we can do is to actually analyze images, because there's so much valuable information that is conveyed through images that at least the Perspective API, at least as far as I know, is unable to analyze yet. So these are just some of the memes that we saw popping up when it came to face mask. Concepts of face masks being uh, compared to muscles, that only, the sheeple that wear face mask, and all of this had very all of these things had very political connotations. One of the hashtags that emerged was "burn your mask," and that it was interesting because that emerged close to the July 4th holiday here in the United States, so Independence Day holiday. And so one of the memes that we saw were like people barbecuing and burning their masks, just like in that image at the bottom of the slide. So we decided to focus on face masks. And also, one of the things that we tend to do in our program is we really look at hashtags. And we think that tracking hashtags offer very valuable information when it comes to public opinion and where people stand on an issue. And so we saw that, we also had someone had suggested to us that we look at the work by Rogers, which is, how people, it's the concept of positioning and counter positioning. And we saw this happening on hashtags where, if there was a group that was using wear a mask, please, then there would be other groups that would be using contrary or counter hashtags like, I will not comply, or no mask, or unmask, maskless. So we thought this was a really good way of thinking about how do we go about collecting data if we were to look at public opinion and attitudes on the use of face masks. And in the US, which is really what I know mostly, there were two prominent public health campaigns that used hashtags as part of their promotion efforts. One is the hashtag Mask Up by the American Medical Association and other partners, and then CDC's Wear a Mask. So these are two, public health organizations in the United States, and these were the efforts that they used, and hashtags were a big part of that effort on social media. At the same time, we saw individuals as opposed to organizations, right, come up with their own hashtags. Burn your mask, as I mentioned, became very popular around the July 4th holiday. And so here's an example of a verified account, verified user who used this hashtag. And then there was also this anti-government sense that you got to with this issue, which I think this was very, very much the case in the UK, where people were really upset about lockdown measures. And that whole concept and hashtag of "I do not consent, we will not comply," which was mostly emerged as as anger against those lockdown measures, then started being applied also to face mask wearing. So we thought this was also very interesting. We had some theoretical concepts, and I won't bore you with with the details, but when we are doing this research, it's always important to connect it back to the literature and what other people have done and build on that. And so there were three main theoretical concepts that we focused on. The first one comes from the risk communication literature, which is used a lot in public health preparedness and disaster management. And it's Peter Sandman's 1993, risk equals hazard plus outrage. And the idea here is that risk perception is a sum of how much people consider something to be a hazard, like really something that will affect them, and how outraged or emotional they feel about it. So that was the first theoretical concept that we used. The second one comes from interpersonal communication, which is my background, and it's the idea of verbal aggressiveness. In communication, we treat it as a trait. So it's a disposition that people tend to have as to whether you're more or less verbally aggressive, but there's an entire literature on that. So we wanted to take from that. And then finally, from social psychology, we focused on the concepts of pluralistic ignorance and false consensus effect. And the last one is, I think, very important to us because there is this idea when you are part of sometimes the minority, that your views and your opinions have more traction than they actually do. So this false consensus effect is kind of in your mind. Um, you think that there are more people agreeing with your point of view than they actually are. And so we were interested in that dynamic as well. We had two main research questions for our study. The first one was we wanted to see, how toxicity scores compared between tweets of anti versus pro-mask sentiment hashtags. And then we also wanted to compare toxicity scores across the individual hashtags that we looked at. And just to make sure I made the connection, when it comes to verbal aggression, toxicity and verbal aggression are pretty much linked, right? So verbal aggression has different ways of manifesting. It could be an insult, an attack to somebody's self-concept, the use of hateful language. So toxicity, as it is laid out by the Perspective API and all the different types of toxicity scores that you get, pretty much aligned with how we conceptualized the construct of verbal aggression in the communication discipline. So this was very useful to us. And so that's why we said, okay, we're just gonna focus on toxicity scores in this paper. We also went ahead and created a matrix for interpreting toxicity scores. And when we did this, we started off by Grust et al., Anatolis, and Philip, I believe, and I'm blanking right now on the third author's name, but the threshold of 0.70 as a score or higher as a proposed threshold for high toxicity. And so then we also decided, well, if we're going to do that, then we should come up with some threshold for what we would consider to be low toxicity scores. And so we decided to put that at 0.30. And I will go into this a little bit later, but one of the things that we found is there's a very tricky area on the 0.50 and 0.60 toxicity scores, where, if you really, I mean, this is all obviously very subjective, but if you really read some of those tweets, they may not be using the particular keywords that the API is looking for, or the machine learning algorithm is looking for, but they can be very toxic. So all those things, are things to have in mind when you're doing this kind of research. Anyway, so we created a matrix. What would it mean to have a tweet where the user shows that they have a perception of the risk of getting COVID as a high hazard, mixed with a very high emotional reaction to the issue. And same thing, we did it for users. How do users express that they perceive this COVID-19 to have a low hazard, low risk to them, but then, also have a low or a high emotional response. So we just created a matrix as a way to interpret social media messages using Sandman's model and then Grust et al. Thresholds. Okay, so I think this is probably the most valuable part of the presentation is how we went about collecting data and analyzing data and how things that we have learned in this process that might be useful for you as you do this research. The first thing is because we decided that hashtags would be our focus when collecting data, we started off by using Hashtagify, which is a free tool that's available online. And using Hashtagify, we just added queries, and let's see, yeah. So this is what the Hashtagify page looks like. And so we started looking at some of the main hashtags that we had seen from the CDC, from the AMA, that we had seen in our initial reading of Twitter and the conversation around face masks. So we started with Hashtagify, and we used Hashtagify basically to help us identify other hashtags that were also popular during the time of our research that either reflected either pro or anti face mask sentiments. After we did that and we identified the hashtags that we were going to focus on in the research, then we went to Netlytic. And again, I really, I emphasize this because it's so useful, but there's so much you can do with Netlytic. And one of the great things you can do with Netlytic is that it helps you collect Twitter data very easily. And so what we did is we just created data sets on Netlytic, focusing on each of the different hashtags that we had identified. And we just set Netlytic to collect data every 15 minutes for a number of days. We'll tell you later how we then narrowed down the time frames because it was just way too much data, right? But then we used Netlytic with two main purposes in mind. First, to extract the data from Twitter. So all those tweets are publicly available, right? And we got Netlytic collecting the data. And then the second thing that we used Netlytic for was just to create a network visualization. And I always like creating a network visualization because it gives me I'm a very visual person. It gives me a map to look at the different communities, how people are clustering. Can you see the clusters by hashtags? What are the main, who's driving those hashtags? So it's just a lot of, I'm just a curious person. And so it's a lot of really cool information for me to have. Once we did that, then we went to Communallytic. So Netlytic, with Netlytic, you can download the data sets with all the information, and it has, the description, the title fields for the tweets, the account usernames, the handles, timestamps, all of that. And then when you go into Communallytic, Communallytic provides you with the template that you need to format your CSV files in order to upload them and do the analysis. So basically we took data sets for each of our hashtags. So we had 8 hashtags total. And so we took the tweets for each of those hashtags. We formatted that data that we had from Netlytic into the templates that Communallytic recommends that you use for uploading, and then we uploaded them as CSV files. And so we just ran analysis for each of those files separately until we got toxicity analysis for each. And then the last step in our research was we went back to the model of risk equals average plus hazard plus average by Sandman and the thresholds suggested by Grust. And we wanted to see how, some of those tweets fit that model that we had, we were interested in looking at. So the first results from Hashtagify is we found that the hashtag wear a mask, and this was the hashtag that was promoted mostly by the CDC, was the most popular pro-mask sentiment hashtag used in the period of our study. So we started looking at all this in July of 2020, but we really started collecting most of the data around late July and then August, all the way through December. And we identified some time frames after that, because there was just so much data that we thought were key turning points in the debate around face masks. This is a figure from the data, with the data we collected from Hashtagify. And these are the 8 hashtags we decided to focus on for our research. In the pro face mask camp, we looked at hashtag wear a mask, hashtag mask up, which was the AMA hashtag, wear a damn mask, and wear a mask, save a life. And in the anti-face mask sentiment camp, we looked at we do not consent, we will not comply. And those two we ended up merging, and I can go into that later. No masks, masks don't work, and masks off. And we also looked at the data for just regular hashtag masks so that it would serve for us as a baseline. And the colors here are pretty straightforward, but wear a mask clearly had the greatest traction on Twitter. And there was, another great thing about visualizing data is that you can see peaks. And so those peaks may suggest an event that's going on at the time that you may want to look into. Why is that hashtag being driven? What is happening, publicly, politically, that might be causing a surge on a particular or a trending topic. So I always, I like to look at those peaks as well as, slumps. Then when we went to Netlytic, we found that there was a lot of data, which is a problem sometimes, especially, if you don't have big computers and all that stuff. But we saw that there were over 4.8 million mask-related tweets that we were able to collect. So I'm sure there's many more, but that we were able to collect from July 18th to December 2nd of December. And so what we did was to make it manageable for us. We focused on 4 key events, and I can in the Q&A section, I can go back to those events in particular, but T4, so T2 and T3 were close to election time. T1, I believe, was the first time that masks became not publicly mandated in the United States, but kind of there was a clear instruction by public health organizations to wear face masks. T2 and T3 were around election time in the US. And then T4 was the Thanksgiving holiday. And there was a lot of resistance from the public because not only were people, asked to wear masks, but there was also a suggestion, or actually a recommendation, to not travel and see family during the holiday. So there were a lot of people were angry. And so we thought that was also a very good time to look at the conversation online. And what we found was, pro-mask sentiment tweets significantly outnumbered anti-sentiment tweets throughout the 4 key time periods. And this was a very interesting finding for us because of that false consensus effect that I mentioned at the beginning, which is, when you're part of a group and sometimes part of a minority, you may think that your views are a lot more popular than they actually are. We were surprised. We thought there would be more resistance that would be visible online. And we were surprised just how overwhelming the amount of pro-mask sentiment was online. And, we can discuss this further about, the platforms themselves and how much this is because of moderation efforts and all of that. But at least that is what the data told us. The story that the data told us was that the anti-mask sentiment was really just a very slim minority of the entire conversation on Twitter. This is the visualization that we did with Netlytic. Again, this is something that I always find very useful. Network properties tell me a lot about just how big a network is it centralized or not? The modularity, like how close communities are to each other, is there reciprocity? And one of the things that, when you're looking at a big issue like face masks or vaccines, all these networks are, a map like this just tells you how much of a public square feel there is to this. Like there's really not a very centralized network, because the issue itself lends itself to so many conversations. In this visualization, I wanted to note which areas of the network graph have the most concentrated anti-mask sentiment, and it's the areas that are marked in rectangles. So you see it's a very, just very particular areas, and really not a big part of that network. And then the circle, because we were doing this around the election time too, I wanted to identify the area that mentioned, this is a name network, so mentioned the account of real Donald Trump, but that's, that doesn't mean that those tweets were anti-mask. They had actually both anti and pro-mask sentiment tweets. They just happened to also mention real Donald Trump. All right, so then we went to Communallytic. So we downloaded our data from Netlytic, our Twitter data from Netlytic. We formatted them in the CSV using the CSV templates that anyone can download from Communallytic. And then we went ahead and created separate data sets for each of those different hashtags that we were focusing on, and uploaded them using the CSV file feature on Communallytic. And I believe, I don't know if this, Anatoly, I don't know if it's still the same, but I believe there's a limit of about 10,000 cases that you can download in upload in a CSV file. You can clarify that for me.
Yeah, I can clarify. There's a limit on the file size. So one way to get around it is to use a gzip program to archive it, to condense it. Also for the pro version, where we have a little bit more space and infrastructure to play with, people can actually now upload JSON files. So if you are collecting something using Twitter data from other programs, and you have a bunch of JSON files, so that feature actually allows to upload multiple JSON files at the same time. Yeah.
Okay, that's great. I might want to come back to you on that later. So we uploaded, and then we got our toxicity analysis from Communallytic. And the following slides are direct, like straightforward results. What were the average toxicity scores when we looked at anti-face mask sentiment hashtags versus pro-face mask sentiment hashtags. We saw that the average toxicity scores for anti-face mask sentiment hashtags were almost always, we had an exception, but almost always higher than the pro-face mask sentiment. We also saw mean difference in 7 types of toxicity scores. So the Perspective API has more than 7 different types of toxicity scores, but the ones that we used are, I guess we call it the productive, I forget right now, or production toxicity scores. These were, by the way, the 4-time periods that we looked at, July 2018, 24, September 29 to October 5th, which I believe was when the first presidential debate happened, as well as President Trump at the time had to be taken to Walter Reed because he had tested positive for COVID. November 3 to 11, that was obviously the election here in the United States. And then November 25th to 28th represents Thanksgiving. So there was a clear spike, right? So I really again like to look at where the peaks are when it comes to time. So there was a real spike in toxicity as we got closer to election time. And that's not surprising if you think about it. And then looking at the thresholds that we used from Grust, from Anatoly's work, the orange portions of this bar graph represent the percentage of the data set with 0.70 or higher in toxicity scores. So again, when you look at anti-face mask sentiment and look at it in terms of time period, so you always see that anti-face mask sentiment is having a little bit more or a lot more in some cases than pro-face mask sentiment hashtags. And so I'm just going to jump ahead because I think I may be a little bit running out of time, but you can definitely take a look at the article. I'm happy to ask also any questions if you haven't had a chance to take a look at it and want to take a look at it after this conversation and then have any other questions. I'm happy to answer them. I'm providing my email at the end. We took some of those tweets that we found, some sample tweets, and we plugged them into the matrix we had created. One of the things that I think we have definitely come to be very mindful of is when we shared some specific tweets in our papers, if they're not from verified or public organization accounts, to black out the name of the user. And I think that that's definitely something that, moving forward should be best practice. And then, the conclusions, we found that overall anti-mask tweets were more toxic than or had a bigger probability, higher probability of being considered toxic than pro-mask sentiment tweets, except for wear a damn mask. And wear a damn mask is a pro face mask tweet, but the word damn in itself is considered a swear word. And so, we would have expected the toxicity scores to be higher. When we took that word out from the hashtag and we reran the analysis, we found that the toxicity scores significantly dropped. And so another kind of consideration that we have is just how one word can really affect the results of your toxicity analysis. Masks don't work, which we thought would be a hashtag used by people who may be more evidence-based, like these are the reasons why masks don't work, actually ended up having the highest mean toxicity score among all the anti-mask sentiment hashtags. So we were very surprised to find that as well. Limitations. So our data is only a very small fraction of the Twitter universe. So I would caution anyone into making generalizations from this study and from this data. It also comes from only one platform, and there has been a lot of criticism since we did this study about liberal bias, and then all the very conservative voices leaving the platform or being deplatformed. Perspectives API's own limitations. I think it's a great tool, but like every tool, we hope that it continues to be improved. One of the benefits of tools like this is that you can analyze a big data that a group of 2 or 3 people would never be able to get through. So I take the good things of the tools, but then also I'm aware that if we were to actually read through many of those tweets, maybe we might not necessarily agree with the toxicity score that the API or the algorithm is giving it. The point again about how one word can have such a drastic difference in toxicity scores, I think is something that we should be mindful of. And the fact that so many of the tweets included multimedia content that cannot be analyzed yet with this tool. So all of those are limitations. Also, this was brought up was by one of our reviewers, which I think is a very important point, is that when we thought about toxicity, we really looked at it as a general measure of outrage, but people could be outraged for very different things and in very different ways. So, moving forward, when we do this kind of research, we really are mindful that we need to have a more nuanced approach about the whole concept of outrage and how it might be different by context or just, different types of emotions. So that's the end of my presentation. All the references are listed in the article. And again, any questions, I'll be happy to answer them now or later on if you want to email me. My email is here. So feel free to write it down and use it. Thank you.
Thank you so much. We actually have a question from Alice, who was wondering if you remember why there might be a spike for specific type of toxicity when you look at it over time for threats.
Okay, let me go. But do you remember? Okay, let me see. Where is any idea why threat toxicity went up so dramatically while the other kinds of toxicity took a dip? So this is a very interesting. Thank you so much. This is a really interesting question because one of the things that we found is the way the tool scores tweets with the word kill. And the word kill is one of the main keywords for that threat score. But the word kill could be used in so many different contexts, right? Like, oh, I want to go kill that person. Terrible thing to say, extremely toxic. But, oh my gosh, I would kill for an iced tea right now, right? So like many of these many of these words, oh, kill the virus. That's a great one too. So that threat toxicity score we kept seeing that a lot of those tweets kept coming back, including that word kill. And so that's very interesting. We didn't go deeper into that, but that's definitely something very interesting to note.
Thank you. We have a couple more minutes for your questions.
Okay, I see it. If I may, Anatoly, can I see a question here from Rui Sun. Sorry if I'm mispronouncing your last name. And the question is, can Netlytic collect a combination of hashtags? Yes, it can. And one of the things we found, Rui, this is a very great point that you are bringing up, is that we would see it was really a minority, but we found around 62, I think it was, tweets that had hashtags with opposite sentiments. So like, wear a mask, mask off, right? Hashtags coming from two different sides of the debate in one tweet. So we just decided not to analyze those. But yeah, I mean, and one of the points that we made is how that inserts doubt into the entire discourse, because where do you really stand? Are you standing for or against face mask if you're using both hashtags? Locations of the tweets do you mean, Rui, do you mean if one can set location limits or?
Yeah, hi, thanks. Yes, that's indeed my question. I was wondering whether For example, we can set the geolocation of where it's posted. For example, I only want to collect the data that is posted by users in the States, for example.
Anatoly, do you know if that is a possibility? I haven't really used geolocation or apply a geolocation filter, so I cannot answer that question, but do you know, Anatoly?
Yeah, so this is something we also revisited last time we met when we look at new geocoded operators when you use an API version 2 or Twitter's historical API. There are, search operators like place. You can limit by country. The challenge, or by specific coordinates. The challenge, of course, only about 1% of tweets would be geocoded. So you would be analyzing a very small niche data set. I think if you're able to limit your data set by hashtags that are unique to a particular location, that's probably an easier way to do to grab a wider, more diverse sample.
And then there's a great question, and maybe Alice, you want to join me on research in this because this is really good. Do your results hold up when you remove the hashtags from the corpus before running the toxicity analysis? We did not do that, and that is so cool. And now I feel like I want to leave this meeting and go and see what happens if I did that. So that's great. You know what? I'm gonna go back and check some of this data to see what happens if I were to, I would say probably because of we're a dam mask, clearly because of the inclusion of that word dam was gonna be higher in toxicity. But I do wonder, the other ones should not really change that much because there was no real sentiment attached that clearly on the hashtags themselves. But I think it's a great exercise to do when you're doing this type of analysis.
Yeah, and also it's conceptually whether or not you would include hashtags Twitter users will see.
Oh, I think I lost the feed briefly, so I missed that last part.
They're not behaving well. I was just, can you hear me?
Mm-hmm.
I was just saying that conceptually it's also depends on whether or not include hashtags, because if
Oh, uh-oh. Oh.
I apologize, that kicked me out. We have time for just one quick question, and I see a question from Felipe in the chat room. So if you can use mic, feel free to ask a question.
Felipe, should I just go ahead and answer it, or did you want to say anything? Yeah, I mean, that was the main part of the study, and I should have probably addressed it, but it's a lot more to deal with. We did it in the context of the infodemic at scale. That was the whole focus of the special issue from Big Data and Society. And we thought that toxicity contributed to that infodemic in several important ways. It's not only about disinformation and misinformation, but it's also about noise, especially negative noise, and the effect that may have on a user who's actually logging into social media or trying to find information seekers, right? Trying to find information about, preventive measures in the context of COVID. And then all of a sudden they encounter this very toxic discourse regarding one of those preventive measures, and then the impact that could have on them actually wanting to leave the conversation, not engage, not look for any further information. So we do think there's a clear, that's why toxicity is so important to study within the context of the infodemic. I hope that answers your question.
Great, thank you. Well, please join me. thanking our speaker. Well, thank you for joining us this morning. Very informative presentation, and again, more details in the paper. Let's just continue on. I'm going to skip some of the slides I planned, but they were mostly a recap some of the steps I showed you last week and week before, how you collect the data from Twitter, as well as how to run Toxicity. What I really want to show you today is that, again, tools like Communallytic is, and just like this case study demonstrated, it's just the beginning of your research project usually. And so you want to be able to export your data once you calculate toxicity scores. So in Communallytic, that's what you see right now on the screen. Once you collected the data or imported data from CSV or JSON files and you executed the toxicity analysis, you'll see general stats for the whole data set, and you'll see distribution of stats. But of course, there are not a lot of research questions you can answer with just the averages or distributions. So what happens is that after you ran toxicity analysis, you download your data set, you will be able to actually see toxicity scores attached to each message. And so this is just shows you hit download, download CSV. And so once you open it in Excel or other programs, you will see original data, plus there will be columns corresponding to the common toxicity measures as provided by Perspective. And so this is, at this point, I would like to invite Shahnawaz, who is data scientist at the Social Media Lab, who will tell you one example, show you one example of type of things you can do with data set that you exported from tools like Communallytic. And so this part is a little bit technical, but I thought it might be still very informative for your future work. We're also going to share a copy of the script that Shahnawaz will present, so you can actually execute it step by step. So over to you, Shahnawaz. I'm going to stop sharing my screen.
Let me share the screen. Thank you, Anatoly. Can you hear me?
Yes.
Okay. Thank you, and good morning, everyone. I'm Shahnawaz Tarwala. I'm a data scientist at Social Media Lab, and today I'm here to present the analysis we have performed on Twitter data using Python's and Google Collab's Jupyter Notebook. For this analysis, we have collected data of replies to then President Trump's tweet about contracting the COVID-19. The dataset is a collection, is collected in a similar manner as explained by Anatoly earlier using Communallytics and Perspective API. It consists of close to 300,000 replies to Donald Trump's tweet, announcing his COVID-19 diagnosis, and it was posted on October 2nd between 6 a.m. and 12:30 p.m. It consists of tweet IDs, tweet toxicity scores, which we calculated by using Google's Perspective API, and the tweets availability status values, which we checked with using the Twerk library. And if you want to download this data set, you can do that by using this link. It is hosted on Dataverse. And also, you can also look at the tutorial which we have posted over, which we have published toxicity analysis of this Twitter thread on Communallytics with this link. As I mentioned, the datasets consist only Twitter ID, tweet ID, toxicity score, and tweet status. This is because we have stripped the metadata associated with the tweet as per Twitter's API policy. So if you would like to collect other other metadata elements and examine other potential relationship between them, you would need to recollect original tweets using a tool like Hydrator first. And here, this is link will give you to the Hydrator's GitHub documentations on how to use that. Now that we have collected the data sets and for analysis, we are using Python with the Jupyter Notebook. However, for data analysis, there are other tools, for instance, Excel, and Excels can also be used for exploratory analysis because it's an easy to use and it's a user-friendly interface. Moreover, for Excel, you do not have to write any codes for the analysis. However, when it comes to analyzing large data, Python has an upper hand. It is designed to be scalable and it can handle millions of data efficiently. In addition, Python is an open source language. What that means is that it has a community in which anyone can contribute to the project. Because of that, hundreds of Python libraries are publicly available and with its documentations on how to use them. For instance, pandas and NumPy are the standard libraries for data analysis and manipulations. Further, we can use the Python to easily automate the job, and also we can easily connect to database that are hosted on cloud instead of a local machine via Python. So because of this, all these advantages, we are going to use Python for our analysis. And to simplify the coding in Python, many programmers use Jupyter Notebook. Jupyter Notebook is essentially an integrated development environment that acts as an interface between the user itself and the Python. It supports multiple programming language, including Python, R, and others. Thus, you can use a single tool to analyze analyze using different programming language. Jupyter Notebook is a web-based application, and it allows users to create and set code and documents easily. And it supports code, tags, and interactive data visualizations. Jupyter also allows the user to view the results of the code in line without depending on the other part of the code. In the notebook, every cell of the code can be potentially checked at any time to draw an output. Because of this, Jupyter Notebook helps in inline printing of the output, which becomes an extremely useful for the exploratory data analysis process. Now, there are several other reasons to opt for Google Collabs instead of just a plain Jupyter Notebook. And Google Collab holds a Jupyter Notebook, and it is a free tool. You can just have to sign in to your Google account and take the advantage of its free resources. It comes with several pre-installed libraries, such as Pandas, NumPy, and Matplotlib, and other machine learning libraries. In comparison to just a plain Jupyter Notebook on your local machine, everything is saved on your local system, on your laptop or computer. Here in Google Colab, everything is saved saved under your Google Drive account. Thus, your notebooks are accessible to you from any device with a simple Google login, just like your Google Docs and Google Sheets. One of another great feature that Google Colabs offer is its collaboration feature. If you are working with multiple developers on a project, and in that case, it's a great to use a Google Colab, just like collaborating on Google documents. You can co-code with multiple developers using a Google Colab notebook, and besides, you can also share your completed work with other developers. You can also just download the notebook in HTML format, in PDF format, and share the file. Google Colab also gives you the dedicated storage and processing for your project. And from personal experience, for some project, these resources make a huge difference, even for small projects. It gives 13 GB of RAM and 110 GB of storage space for each notebook. Now, this is an image of a Jupyter Notebook hosted on Google Colab, and you can also get the complete notebook of using this link. Now that we have covered the Python and Jupyter Notebook and Collabs, let's look at how we are using these resources for the toxicity analysis of reply to then President Trump's tweet about contracting COVID-19. We'll just use this link.
And I just shared the link in the chat room.
And you just have to click on Open with Google Collaboratory. It will take you to the Google Collab web page, and here we have our notebook. Here we can see that here I am signed in with my account, and this is essentially a Google Jupyter Notebook set on Google Collab. And here we can see you connect to the remote storage and RAM by clicking on the connect. So now we are connecting to the resources provided by the Google Collab, and it's initializing a notebook. So now we are connected, and here we can see that we have around 13 GB of RAM and around 110 GB of storage for our notebook. Now coming to notebook, this block of code is called a cell. It is here we have to write our codes. At the beginning of any program, we will first have to import the required libraries for the project. In our analysis, we are using pandas, which is the most used Python package for data analysis and exploration. Then we are importing cbands and matplotlib libraries. They are used in a data visualizations. Just to make it easy to refer these libraries in a code, we have assigned an alias for each of them. Like here, we will use pt to refer to pandas and so on. And to make the visualization as an output for the code of the cell, we will use this line of code matplotlib inline, so that our visualization are outputted for each block of code. And to run this block of code, we just have to click on the play button. So now the code is being run, is being executed. All this package are loaded in our environment. And okay, so to load the data sets, I know that Anatoly has shared this link of the data set that we captured from Google, from Twitter, and the data set is in CSV format, and Pandas has the read_CSV function to load any CSV file. But if you have your own data set, you can use that as an input here. To refer to this import further file further in the analysis, we will save this data into a variable, and let's call it as a PDF. To look at the PDF data, we will use the head function, pandas head function, with the saved PDF file. Let's first run this file to load the data into a PDF variable. And let's see what our data has. So this is a snapshot of our data sets. It has Twitter ID, Twitter status, language user and the tweets, and all the toxicity scores captured from the Communallytics. And if you want to see a brief information about the data set itself, you can use the pandas info function on the PDF variable. So here we can see that there are 10 different columns in the data sets, and each column has around 298,000 values. And also it gives us the information about what is the data type for each column. Here for the Twitter ID, we can see that the data type is integer. For language and tweet status, it's object, and so on. And it also gives you information about how many memory this data set is using in the environment. And for our data set it's 25 plus MB. And So to identify now how many unique languages are there in the whole data sets, we will use this line of code. And here first we will select the language column from our data PDF data sets, and then we'll use the unique function, which will by which we will able to see all the unique languages used in the replies. Let's run this block of code. Here it outputs is an array of all the unique language keywords used for the in the data sets. Here en is for the English language, unt is for the unidentified language, and all the other possible languages for in the data sets. And just to see that how many total languages are there in the data sets, we will just pass it into a len function. It will output the number of different unique languages in it. So we have around 62 language in our data set. Now, similar, if you want to see what are the top 10 most used language and they're in the data and how many times they are used in the reply, we can do that by this line of code. So we can see that English is the dominant language. It is used by in 247,000 tweets out of 298, and there are thousands of other tweets on other languages. And also we have used the English language for our analysis of toxicity. So we are filtering out only the data set of tweets containing English language. And here now the data set will only have the English language in it. Now that we have the English language data set ready, from this data set, we will create a feature data that will have the feature called feature toxicity score. That is toxicity, severe toxicity, profane, identity attack, insult, and threat. And we will save it in a new file, new data frame named PDF English features. It will have all the toxicity features in it. Now, to explore the range of toxicity scores in the data sets, we have built this histogram to visualize the different score of each toxicity attributes. But because of the time constraint, I'm not going to explain the code, but it is here for you to explore. And you can find more detail about the distribution on this distribution on the tutorial post which we published on Communallytics. Now, while there are different scores are representing different attributes of toxicity, some of them might have highly correlated, for example, toxicity and severe toxicity. To find out to what extent the toxicity score are correlated with each other, we can use the correlation matrix. To get the correlation matrix, we can use the correlation function on top of the PDF features data sets, and then we have saved it into a new data frame called core_matrix. Now, to visualize this matrix, we can use to visualize this matrix. So we will use the sequence heatmap function, and I'll show this one slide again. And this is the output of the correlation matrix. We can see that for each pair of toxicity, the matrix represents correlation value between 0 to 1, where 0 corresponds to not correlated and 1 corresponds to highly correlated. The values are represented in a correlation matrix in shades of red, from light red, which are values close to 0, to darker reds, values closer to 1. And here we can see that the toxicity, severe toxicity, profanity, identity attack, and insults are very highly correlated with each other. That is, the correlation values are higher than 0.7, whereas the threat toxicity attributes is moderately correlated with the remaining toxicity attributes. We can see that by its correlation value, which is less than 0.7 and more towards 0.3 and 0.4. This means that in general, a high value in any of these toxicity attributes will correspond to a higher value in other toxicity attributes except of threat toxicity, which capture a somewhat different aspect of online exchanges. And for our analysis, we will only examine the toxicity attribute because they can be used as a proxy for the other majority of the toxicity attributes. And to further enrich our data sets, with the help of Python's Torque library, we collected information about the availability status of each tweet. The purpose of this exercise is to identify whether any of the tweets or user from the data set are still publicly available, or if they have removed by Twitter for violation of some of its policies. And let's see what are the possible values this Twitter tweet status column has. And it has tweet okay, tweet deleted, user suspended, user protected, user deleted, and tweet block.
And if I can jump in, Shakamas, just quickly where we got those numbers. So those were calculated using a separate Python library called Twark.
Yes.
If anybody is interested to see the sample code, Python code, we're happy to share it. But what we also realized, and it might be useful as a feature in Communallytic. So if you have Twitter dataset and Communallytic, in a month or so, you should be able to run this check automatically within the platform, so you don't have to worry about Python. So when you export your data set, the values will be there. Okay.
Okay. Now to find out how many tweets are there for each type of tweet status, we will first combine all the tweet data based on the tweet status, and then we are counting all the number of unique tweets for each language, and renaming that column to count and sorting it in and descending order to get the job. Here in the output, we can see that the tweets okay is used by the status, which is the majority one, and there are some other tweets with other possible tweet status. We can visualize this data in a bar graph using the Cban library. And here we are using the log scale because the data is highly skewed towards tweet okay. So to get a fairer representation of another tweet status, we have used log scales. And now that we have that, we can now compare tweet status with the Twitter toxicity scores to investigate how likely the Twitter is to take action against those who post toxic tweet messages by either suspending an account or blocking a tweet. And in other words, are blocked tweets more toxic on average than tweets that are still available on Twitter? To examine this, we can take a look at an average toxicity score in relation to the availability status of tweets on Twitter. As mentioned earlier, as the toxicity attribute is highly correlated with other toxicity score, we will use that for this analysis. To do that, let's first create this new data frame, and that will have an average toxicity for each tweet. First, we combine all the data based on the tweet status, and then we will take the toxicity feature, and we will, and as we want to calculate the average toxicity for each tweet status, we will say find average with the aggregate mean function, and then reset that index, the column name from toxicity to average toxicity. We can plot the same data to better even understand it with the Cban's bar chart, and The output so here shows that the average toxicity score for tweets with different availability status are provided by the Twitter API. Tweets that are still available has the lowest average toxicity value of 0.04, while tweets that has been blocked by the platform have the average toxicity value of 0.82, which is twice as large as the values for other categories. This suggests that Twitter does act on tweets that are especially toxic by blocking them. However, since only a small proportion of tweets, that is around 600 to 700 tweets, has been blocked by the platform, this finding must be taken with some cautions. We also expected that the tweets posted by accounts that are now suspended would also have a higher toxicity score related to the tweets that are still available on the Twitter, that is tweet OK status. However, the difference was only marginal, comparing 0.4 to 0.34. This is likely because user can be suspended not only because they attacked others by posting toxic tweets, but also because they violated other community norms such as copyright or impersonation policies. Thus, toxicity scores are not the only variable that may predict if an account will be suspended and vice versa. Further, since for this analysis, we are only examining the text data, and it is based on textual part of the tweet. It does not take into account for the potential toxic media files or URL attached to the tweets. So that's the analysis, and you can also get this. Anatoly have shared the link to this notebook, and you can explore more to this. And one more thing, that all the Python codes, there are many publicly available libraries and documentation which you can use for your explorations of your data sets. Thank you, everyone.
And thank you, Shahnawaz. And so Rui has a follow-up question. How did we get blocked to deleted tweets? So what happens is that we've collected all of the replies to the Trump's tweet, and they were, almost 300,000. But then we checked whether those replies are still available a few days later. Because what happens if a tweet is toxic, harassing someone, and people flagged it, Twitter would block it. Sometimes users change their mind and they would delete it. So the trick is actually to do this check a few days later after you collected your original data set. And what happens over time, the percentages may change. So if you're planning to use it in your research project, you have to conceptualize, to think about how far from the original data set do you want to go, 1 month, 6 months, and so on. Interestingly, as on a side note, we did a similar project where we look at how many tweets, toxic tweets, were deleted 1 year after we've collected them, and that was part of the paper we presented, violence against women from India on Twitter. And so majority of tweets, harassing tweets, were still there on Twitter. So sometimes even 1 year may not be enough to, depends how Twitter approach the blocking and deletion. And of course, if users suspended all of their, or became protected, all of their tweets will disappear. Hope it answers your question. All right, on this note, it's 1:30. I know many of you have to run, but if you have quick questions, we will stay around for a few more minutes. I will stop recording, and I hope to see you all again in 2 weeks when we're going to talk about social network analysis with Communallytic. And Paula, thank you again so much. Great presentation.